what we're doing here. Because so far what we've been doing is we've been going over solving system of linear equations, trying to find the values of x and y that will make both equations true. So let's close the Chromebooks for now. Let's pay attention up here. Now we've gone over multiple ways to do this. The first way we went over solving these was by graphing. So you graphed both equations and saw where they crossed, where they intersected, where the x and y values were the same. So that's what we did first. Now the next way we did was substitution. Substitution, where we solved for one equation and plugged in the other. We substituted it in. Now the last way we're going to look at is elimination. And out of these three, substitution and elimination are more the most used ways to solve them. Elimination is actually the most used, or most people like better, than substitution or graphing. Now what we're talking about with elimination is we have these steps here. But when we eliminate, when we use elimination to solve a system of equations, what we're doing is we're looking at both equations and then first picking out one variable to eliminate. We're wanting one of these variables to cancel out completely. Because again, the x values and the y values for both equations are the same. We're looking for what value is going to make x be the same, y be the same. So for our solution, these here, the x and y values are going to be the same. So what we do is we want to get one variable. We want to pick one variable we want to eliminate. We want to pick one variable we can eliminate from both equations. So when we look at this here, do we want to eliminate x or y first? Do we want to eliminate x or y? Well, here, what are the x's? Well, we have 3x and 3x, so the x is the same. Well, yes. We have 2y and we have 2y. So they're the same. So this one here, it really doesn't matter which one we pick first. We just need to pick one of them. So let's just pick x. I want to eliminate x first. So then we are either going to add them together or subtract. Now, depending on where you learn this first, a lot of them are going to make it, they have a set rule that we're going to make the signs be the same, so we always subtract. Now, the way I think about it is if the signs are the same, you subtract. If the signs are different, you add. Because a negative and a positive, if they're the same number, negative 3 plus 3 is what? 0, yes? If you have $3, you lose $3, you're at 0. So looking at this here, now say I added all the way across. Well, 3x plus 3x would be what? 6. What's 2 plus negative 2? 0. So if the signs are different, we have the same number, and we add, they would cancel out, yes? Say we subtracted. Say we didn't add. Let's say we subtracted. Well, 2y minus negative 2y. Well, the negative and negative make a positive, so it'd be 4, yes? What's 3x minus 3x? 0. So if the signs are the same and we subtract, they will cancel out. So here, since we chose x, well, 3x minus 3x is 0, yes? Okay, I'm going to rewrite these so I'm not writing over the top of that. So looking at this here, we're going to subtract. Well, 3x minus 3x will cancel because 3 minus 3 gives me 0, yes? Now here we have 2y minus negative 2y. Well, the negative and negative, as we just said, will make a positive. So 2y plus 2y gives us 4y. Now over here we have 4 minus negative 4. Well, the negative and negative will make a 4 plus 4 is 8. Okay? Any questions on this here? So really, we picked x, and since the numbers were the same, we went on and subtracted. Now, there might be some steps if it's not the same, and we'll cover that here in a little while. But doing this here, combining these two equations, what have I done? I've taken two equations with two variables, because we had two equations with x and y, yes? I combined them, I subtracted them from each other, and now what? I have an equation with what? One variable, yes? Mm-hmm. So we'd subtract all of them. So we're looking at example 1. So what we did is we're going to try to solve this using elimination, and we're eliminating one variable. Now we picked x, and since the signs are the same, we subtract, because 3 minus 3 would give us. So we're going to subtract everything. So we subtract the x's, the y's, and the numbers. So we subtracted the x's. Well, 3x minus 3x gave us 0. 2y minus negative 2y. Well, the negative and negative made a positive, so that gave us 4y. And 4 minus negative 4, again, negative and negative made a positive, gave us 8. So now I'm left with what? 4y equals 8, yes? Hey, let's solve that for y. So we found the value of y. Any questions on this here so far? So what am I missing? What do I need to solve for? The value of x, yes? I could pick either one of these equations. So 3x minus 2y equals, I can pick this equation. Well, we know what the value of y is, yes? Plug it back in. And we're going to solve for x. Well, 3x. Negative 2 times 2 would be negative 4. What do we need to do next? We need to add 4 to both sides, because we want to get x by itself. So the easiest thing is going to be to add and subtract, move everything over to the other side. Well, negative 4 plus 4 is, these cancel, giving me 3x. Well, negative 4 plus 4 is 0. Well, and last but not least, we've got to divide both sides by 3, which tells me that x is equal to, so our solution is 0, 2. So what we're going to do is when we use elimination, we're going to pick a variable that we want to eliminate. So here we chose x. Okay, 3x and 3x that we have. Since the signs are the same, we subtract. They were both positive, so we subtracted. Canceled it out, solved for y. Once we found the value of y, we plugged it back in and found the value of x. Questions on this here? We ready for the next one? Okay. Solve the system of linear equation by elimination. Now, one of the biggest things with elimination is we need the number in front of the variables to be the same. We want it to be the same. Because if they're not the same, we can't just add the two equations together or subtract them and get a variable to cancel out. Let's look at this here. Well, I have 3y and I have just y, yes? So if I add these, well, 3y plus negative y, well, 3 minus 1 is 2. Okay, adding doesn't work. Say I subtracted. Well, the negative and negative would give us a 3y plus y is 4y. So as it stands right there, there's no way I could add or subtract and get those two to cancel out completely, yes? Okay, now before we do anything too radical, let's look at the other variable. How about x? Well, I have 2x and 2x. I'm not really focused on the sign yet. But is that the same? 2 and 2? Yes. So here, I would pick x again because the numbers are the same. They have different signs, but the numbers are the same. Because this is where the little bit of a hitch comes in. Because with substitution, we saw if both equations didn't have a variable by itself, it made it harder to solve. Because we didn't even hit one that had something like this here, 2x plus 3y equals 4. Well, that would be harder to solve with substitution because there's numbers and we're going to have to do a lot more, yes? Graphing was tricky because, well, if it didn't have an intersection at a whole number, it was hard to find. Fractional numbers, fractional answers were hard to find with graphing. Now, with this here, the trick is if we don't have one that's the same number, we're going to have to make it be that way. Now, we're not going to have one of those yet, but that will be coming up. Now, luckily for us, the x's are the same. 2x plus 3y equals 4. And then we have 2x minus y equals negative 8. So when we look at this here, the numbers, or the variable I want to eliminate first is the x again. And the reason we're eliminating x is because, well, we have 2x and 2x. Both of them have a number 2 in front. So we can eliminate this. Now, to figure out what we're doing, because, I mean, we have addition and subtraction. Yes, we have both. When the signs are the same, we subtract. When the signs are opposite, we add. So here, would we add or subtract? We would add, because we have what? 2 and negative 2. The signs are different. One's positive, one is negative, yes? When the signs are different, we add. When the signs are the same, we subtract. So here we would add all of them. Now, negative 2x plus 2x, these will cancel out, because negative 2 plus 2 is 0. Now, 3y plus negative y, or 3y minus y, will give us 2y. So that's just figuring out the signs as a whole. Because what we're wanting to eliminate is the 2x, yes? Since the signs are different, we add all the way across. Because what we do to one thing, we have to do to the other. Now, for us here, we're eliminating one variable at a time. So here, we're only going to have to eliminate it once. So have we eliminated x? By adding. Yes, so we have to add the others. So 3y plus negative y. So 3y plus negative 1y, or 3y plus negative 1. The plus and the negative, so 3 plus negative 1 is the same as 3 minus 1, which would give us 2. Okay? Does that make sense? And now our last one over here, 4 plus negative 8, which would be negative 4, because it's the same as 4 minus 8. Questions on this here. So what do we need to do next? Well, now we can just solve for the value of y. So we can divide both of these by 2, which tells us y is equal to negative 2. Y is equal to negative 2. Any questions on any of this here so far? Okay, well now we're going to have to do exactly what we did with the one before, is we're going to pick one of these two equations. I'll pick the bottom one. X minus y equals negative 8. Well, if I want to solve for the value of x, I'm going to plug the value of y into it. And since we know the value of y is negative 2, we plug negative 2 into the equation. So we get negative 2x, or 2x, sorry, not negative, 2x minus negative 2 equals 8. Well, here the negative and a negative make a positive. So we have 2x plus 2. Now again, we need to get x by itself. So the first thing we need to do in getting x by itself is to what? We need to subtract 2 from both sides, because 2 minus 2 is 0, leaving us with 2x on the left-hand side. 8 minus 2 is 6. And last but not least, we need to divide both sides by 2, which tells us x is equal to 3. So our point for this here is 3 comma negative 2. Yes, sir? Huh? Like where we add or subtract? Oh, the other one? Yeah. We could do the other one, and it would give us the exact same thing. Yeah. Yep. Well, do y'all see what happened here? Because there is an error. Oh, yeah, you didn't put the 4 alive. What's the 8? 8 is what? Negative. What happened here? I didn't put the negatives. I dropped the negative. Yep, so I messed this up here. So this here should have been 2x is equal to negative 10. When we divide by 2, x should equal negative 5. So it should have been negative 5, negative 2. Yep. Yep. So on that last one, I just dropped the negative off the 8, and it changed the whole answer. Questions on this here? Do we get good with this here? We see where I messed up on that one? Yep. Okay. They really like making the x's the same. So let's look at this one here. So we have 3x plus 2y equals 7, and negative 3x plus 4y equals 5. So if I'm eliminating one variable, I need to pick which one I'm going to eliminate. Would we pick x or y?
I would do y.
Or do x? I mean, we can do y, but the thing is we need the number in front of y to be the same. And if it worked out, well here, because we see x is 3 and 3, yes? Do I need to do anything to make the x's the same? No. Now, is it wrong to solve it for y first, or eliminate y first? Well, no. But what would I need to do to 2y to make it be the same as 4y? So, times it by 2, because if I multiplied everything by 2, then the y's would be the same. So that's possible. That's what we'll get into. But I avoid that because, well, if I have a variable that's already the same, x and negative, the x is already the same, I'm going to use it. If I divided this one here by 2?
No. All right, so on the top one,
Mm-hmm. Yep.
Like a point, like a dot, and then 2, so
Because if we multiply by 2, we've got to multiply everything by 2. Yeah, so 2, and then the multiplication symbol 3x. Mm-hmm. Yeah, I use parentheses just to signify it's going all the way across. Yeah, there's nothing wrong with that either. So here we can do the same thing, and now the y's are the same. But we had to do an additional step to get there. So if I can avoid, because I think the easiest way is the best way, if we don't have to do a step, why not? So since the variables, the x is already the same, then we can use that. Now, if it worked out, say, one of those was 4x and 3x, okay, then I would go for that. And we'll see that. We'll come across those in a little bit, because we'll see where the variables aren't matching up like this. And I chose these intentionally to go in this order. So we have 3x plus 2y equals 7, and negative 3x plus 4y equals 5. So we chose x because we have 3 and 3. We have 3. They're the same, yes? Now, would we add them together or subtract them? We would add because one of them is positive and the other is negative. So if the signs are opposite, we add them together. So if the signs of what we're wanting to eliminate are opposite, then we add. If they're the same, we subtract. And we only really get to the add and subtract once we have a set of variables that have a same number in front of them. Now 3x plus negative 3x, well, these would cancel. So that leaves us with 2y plus 4y. Well, 2 plus 4 is 6y. Everything correct so far. And lastly, we have 7 plus 5, and 7 plus 5 is? And last but not least, so now we have an equation, 6y equals 12. I've taken 2 equations with 2 variables to 1 equation with 1 variable. So it's a little bit easier to solve. At this point here, we're going to divide everything by, well, 6y divided by 6. Well, 6 divided by 6 is? Y is equal to? So you got the y value of 2, yes? Okay. So let's plug it in and see. So 3x plus 2y equals 7. So if I plug 2 in for y, you're good. So we plug 2 in for y. Well, 2 times 2 would give us 4. So minus 4 from both sides, which tells us that 3x is equal to. And we divide both sides by 3. X is equal to 1. So the point of the solution is 1, 2. 1 comma 2. Questions on this here? We good with this here? We're starting to see how this flows. You liking elimination better than substitution and graphing?
Do you have a homework thing?
You will. Most likely it'll be tomorrow.
Alright. You want us to finish this paper?
Well, we're going to work through this tomorrow if we don't finish it. You're good. So let's see here. We have this. Put that down. Okay. Let's do this one here. So we have 4x minus 9y equals negative 21, and negative 4x minus 3y equals 9. So which one would be easier to eliminate? X. And the reason we're going to eliminate x is because, well, they're the same. It's going to be easier to work with if they're the same. Now, since the signs are opposite, we're going to add them together. Well, 4x plus negative 4x, that is 0. 4 plus negative 4 is 0. Now, negative 9y minus or plus negative 3y. Negative 9 plus.
But they're the same though.
Because a negative and a negative make a bigger negative.
Lower negative, please.
Yeah, lower negative, thank you. Huh? Mm-hmm. So if I lost 9 and I lost 3 more.
No, why would you add that?
Because here the 4 and negative 4 are opposite.
They're opposite, that's
Yeah. So since the 4 and negative 4 are opposite, we added. So we add across everything. Because it's not so much that the y's are opposite, but since we decided to choose x as the one we're going to eliminate, because the x values are opposite, yes? Because that's the one we're canceling out. So we'd add. So the one that we're eliminating really determines what we're going to cancel out. Now you're right, the y values are the same because they're both negative. But because the x value is the one we want to eliminate are opposite, we add there. So since I added in one spot, I have to add in all of them. Does that make sense? So here we would just combine them. And now negative 21 plus 9 will be negative 12. Mm-hmm. So we get y is 1. Because a negative and negative make a. Mm-hmm.
yeah, right. But 12 times 1 is 12.
Mm-hmm. So negative 12 times 1 is negative 12. Because when we multiply or divide, the signs cancel out. When we add or subtract the same numbers, it just makes them a bigger or smaller version of themselves. Yeah, it's odd. Negatives are weird. Yeah. Now, I'm just going to use the top equation and plug 1 in for y and solve for x. So 4x minus 9 times 1 equals negative 21. Well, 9 times 1 is just 9. Now we need to get x by itself, and to get x by itself, we're going to do what to both sides? So we'll add 9 first. Because negative 9 plus 9 will cancel. So then we'll have negative 21 plus 9. And negative 21 plus 9 is, and it'd be negative because 21 is the bigger number. And last but not least, so we divide both sides by 4, and we get x is equal to negative 3. So the point, the solution is negative 3, 1. Questions on this here? Okay. Because if we wanted to, we could have used the other equation to find this and kind of get this answer. Okay. I'm going to